Okay, today's lesson is L'Hopital's rule, and this is the version for AB calculus, not for BC. When we're working with L'Hopital's rule, it's pretty easy to use. We use it to evaluate limits. Oh, here, let me put a title on here. And it was named for a French mathematician who developed this process. So if I were going to try to take the limit as x approaches 5 of the natural log of x minus 4 over 10 minus 2x. The first thing that I might check out is direct substitution, see if that would work. So plug in the 5 for both of the x's here in the problem. That's going to give me the natural log of 5 minus 4 divided by 10 minus 2 times 5, which is the natural log of 1 divided by 10 minus 10, which is 0 over 0. Now, this answer that we get right here, 0 over 0, is not equal to 1. If you type that in your calculator, it will not give you 1. It's not equal to 0 either. That is called an indeterminate form. And we can only use L'Hopital's rule on limits that yield an indeterminate form, and you have a note card that shows you what all of them are. So when that happens, what we need to do is employ L'Hopital's rule, which says I'm going to set up this limit again as x approaches 5, but instead of taking the limit of the original equation, since it is in a fraction format, I'm going to take the derivative of the top and the derivative of the bottom and look at what the limit of that function is. So the limit of the natural log of x minus 4 is going to be 1 over x minus 4, and then of course you multiply it by the baby, the derivative of the inside function, which is 1. And on the bottom, the derivative of that polynomial is negative 2. Okay, so when I do this limit as x approaches 5, my little stylus is not working so well. It would be 1 over x minus 4. Instead of dividing by negative 2, I could multiply by the reciprocal of negative 2, which means 1 over negative 2, and that's going to give me the limit as x approaches 5 of 1 on top, and then I can distribute, let's see, it'd be a negative, negative times positive, the 2 times x minus 4, so that'd be 2x minus 8. Now, I'm going to try that direct substitution again. That's going to give me negative 1 over 2 times 5 minus 8, which is equal to negative 1 over 2, negative 1/2. And that is the answer for the limit for this problem. Another way that you could double check it, if you have use of your calculator, is to go to the table, go to the graph, look and see what the values in the table or the actual graph itself are approaching when x gets close to 5, like 4.999 and 5.001, to verify that you've done this correctly. Okay, let's take a look at another one. Okay, so here's our second example with L'Hopital's rule. We're going to do the limit as x approaches 0 of the cosine of x minus 1 over x cubed. Now, if you were to do direct substitution here, you would end up with the cosine of 0 minus 1 on the top over 0 cubed. Of course, you can see that denominator is going to come out equal to 0. And the cosine of 0, if you'll remember from your unit circle, is equal to 1. 1 minus 1 is also 0, so this gives you that same indeterminate form of 0 over 0. Probably the most common one that you're going to find. So, I'm going to take the limit as x approaches 0 of, now I'm going to do the derivative of the top and the derivative of the bottom. The derivative of the cosine of x minus 1 is negative sine x over the derivative of x cubed is 3x squared. So I'm going to go ahead and look at what would this give me if I plugged in zeros here. Well, negative sine of 0 on the top is equal to 0 from your unit circle, and 3 times 0 squared is also equal to 0. So what did this do? It didn't really help me that much because I've ended up in the same situation. I have 0 over 0. When that happens, you simply use L'Hopital's rule again. You can keep using L'Hopital's rule until you get something you can find the limit of. So, what is the derivative of negative sine x? It's negative cosine x. And what is the derivative of 3x squared? It'd be 6x. Okay, so now I'm going to plug the zeros in. Negative cosine of 0 over 6 times 0. Well, the bottom is obviously 0. The top from your unit circle, the cosine of 0 is 1, so this is negative 1 over 0. Negative 1 over 0 is not an indeterminate form. So you stop doing L'Hopital's rule at this point. It is, however, an undefined quantity. So that means that the limit does not exist. So you can still get a limit that does not exist when you're using L'Hopital's rule. Alright, number 3. The limit as x approaches positive infinity of x over e to the x. Now, if you plug in infinity, which infinity is not really a number, so you can't really plug it in, but you can look at the end behavior of a function as the equation y equals x is going towards infinity. As x approaches infinity, y is approaching infinity. So this is going to be infinity on the top, and e to the infinity would be like infinity on the bottom, which is not equal to 1, and it's not equal to infinity. This is another indeterminate form. And again, you should have a note card with all of the indeterminate forms that you will find on there. So, we're going to use L'Hopital's rule and take the derivative of the top and the derivative of the bottom and evaluate the limit of the new function, because the limit of that function will be the same as the original. So what is the derivative of x? 1. What is the derivative of e to the x? E to the x. And now, if I plug in, so to speak, infinity, I have 1 over infinity, which we talked about before. Any small number, any really constant number over infinity is approaching 0. And you can always verify that if you have use of your calculator by looking at the table in the graph. So the answer to this one is 0. Okay, our last example for today is the limit as x approaches infinity of e to the negative x times the square root of x. Now, sometimes they give you problems like this that are kind of sneaky because usually we use L'Hopital's rule when we have a fraction, when we have some type of rational function, one function over another one, because that way we can take the derivative of the top and the derivative of the bottom. This, however, doesn't look like a rational type expression, so we have to first rearrange it so that it does, and that's pretty easy to do with that negative exponent. So the top will stay square root of x, but since the e to the negative x is on the top, I can move it to the bottom and make it be e to the positive x. Now, what happens if I plug infinity into both of these? Both the numerator and the denominator are approaching infinity. So that's an indeterminate form, and I'm going to use L'Hopital's rule to evaluate the limit. So, limit as x approaches infinity of, okay, we're going to think of this as x to the 1/2 power over e to the x. So, the derivative of x to the 1/2 power is 1/2 x to the negative 1/2 power, and then we have e to the x here. So, we're looking at this now. If I plug in infinity here, well, it's kind of difficult because it's not really in a very user-friendly format, this function. So let's think about how this would really look if we cleaned it up. 1/2 times, that negative exponent means 1 over the square root of x over e to the x. Oops. Which means that this is the limit as x approaches infinity of 1 over 2 square roots of x times, multiplied by the reciprocal of e to the x, 1 over e to the x. Okay, so I'm plugging infinity in for the x's here on the bottom. I'm taking the limit as x approaches infinity of 1 over 2 e to the x square root of x. Well, if I put an infinity in the x's in both of these, they equal infinity. So I have 2 times infinity, which is definitely going to be infinity on the bottom. 1 over infinity is approaching 0. So the limit is equal to 0. Okay. Your homework assignment for this one is going to be posted on the website, so take a look at that, and good luck using L'Hopital's rule.